Hello, Accelerated Math 7-8 students. We are working in Module 12, and this is Lesson 3, and it is called The Ins and Outs of Basic Rigid Motions, and we're going to be focusing on rotations today. So please turn to that page in your comp book, and here are the notes for today. Okay, so ins and outs of basic rigid motions. As you know, we've been working on basic rigid motions. Those are the motions that a figure has been moved to change it because that's what a transformation is. Today our focus is going to be on rotations. So our goal, today we will practice the rigid motion called rotation. The question that I want you to be thinking about during this lesson is, what must be present for a rotation to occur? Now, something that I want you to look at is, this is a circle, okay? And we call it a unit circle because it has been divided into the 4 quadrants. What you need to know is you need to be able to tell me if we tell you that right here on the circle is considered 0 degrees. And the reason why it's called 0 degrees is if you look on a protractor, a circle begins on the horizontal side, and it always starts with a 0 degrees. So if you have 0 degrees on the right-hand side of the circle, your job is to determine how many degrees it is at each rotation of the circle. So I'm going to move this out of the way for just a second because I need to write on it. So here we have a circle. Okay, sorry it's not perfect. Here is the coordinate plane that sits inside of it. Okay, and we know on the unit circle that this is 0 degrees. If I move on my protractor from 0 degrees up to where the y-axis would cross on the unit circle, how many degrees did I go? The answer is 90. That's where 90 degrees came from, okay? If I keep rotating counterclockwise, so I'm going in this direction. So whenever you start at 0, the unit circle travels counterclockwise. That means we're going in this direction, okay? So from 0 straight up is 90 degrees. Then we keep going on our rotation, another 90 degrees, and what would it be here? You are correct, so that's 180 degrees. So now you know why a straight angle is called 180 degrees. If you keep going another 90, what do you get? 270 degrees, that is correct. And then if you keep going all the way to the end, then you would know that it would be 360 degrees. Because we know that the degrees of a circle in total make 360 degrees because we have 4 90-degree quadrants of a circle, okay? So again, you start at 0, you go counterclockwise, and all of your degrees are positive. You need to know that, okay? So we have our unit circle, okay? Starting on the right-hand side in the horizontal position, it's 0 degrees. If you rotate from 0 up to the y-axis, you now have traveled 90 degrees, and they are positive. So this is a positive 90 degrees. Positive is counterclockwise on a circle. You need to remember that. So we keep going counterclockwise, another positive 90 degrees, and that's how we get 180. Counterclockwise still, another 90 degrees, and you get 270. And counterclockwise all the way back to the beginning, and you get a positive 360. So counterclockwise movements or rotations, let's use the correct vocabulary, counterclockwise rotation gives you the degrees that are positive, okay? Now, so that's very important that you need to know. So each section of the unit circle is broken into 90-degree increments. And when you add up all of those 90 degrees, you have 90 plus 90 equals 180, plus 90 equals 270, plus 90 equals 360. And that's how you get the degrees broken up in any circle. This works for any circle, okay? The reason why we're talking about this circle and rotations is because the rotations are determined by the degrees. So we have to have the use of the circle to identify what the number of degrees are. So when it says rotate a figure 90 degrees, so for example, if I have this arrow right here, and your directions are to rotate that arrow 90 degrees, you're going to have to find the center point. So this is called the center O. We always just call it the center O. And you're going to take your transparency and you're going to copy the center O, okay? And then you're going to copy your figure and you're going to rotate it 90 degrees. So that means you're going to put the pen of your marker back on and you're literally going to take your transparency. This is at 0 and that would be at 90. So when you rotate it along your center, that center has to stay put and you go 90 degrees, this would be where the new position of the arrow would be drawn. So you would trace that arrow in that position where it's sitting right there, and you now have rotated this arrow 90 degrees. Okay? So the way that we would describe this, if we drew this on here, I'm sorry for the overlap, but this is where the new figure would sit. Okay? So this is now, let's say this is figure T. This would be T prime, right? And the way we would say it is figure T rotated, rotated 90 degrees. That's how we would write that. Now, what if I told you that I wanted it to rotate clockwise 90 degrees? Because that was counterclockwise. What if I told you I wanted it to rotate clockwise 90 degrees? Well, again, you have your trace, turn your transparency. Remember, clockwise 90 degrees means you go this way, okay? And so again, we're going to trace our figure down here, right? So we have it loosely looking something like this, right? And this one now is called T prime prime, and you're going to say that figure T was rotated negative 90 degrees. And the reason we call it negative 90 degrees is because whenever you have a negative, you're going clockwise. Whenever you have a positive, you're going counterclockwise. Okay? So this is new information that you need to know. This is a transformation. The transformation that we're focusing on is rotations. Rotations, when they are counterclockwise, they have positive degrees. When they are rotated clockwise, they have negative degrees. So clockwise means that the degrees are negative. You have to know this. This is very, very, very important. Okay? All right, so let's go back to our notes over here really quick to make sure that I am following what we're supposed to be doing. So there's your unit circle. We figured out the degrees that we're supposed to do, and then show what you know. All right, the show what you know is that you identified each quadrant and how many degrees there were. So what you need to write down in your notes next is rotations are positive when they rotate counterclockwise. So if you take a look at this picture, it's kind of really helpful to help you see it. Remember that we always start in the horizontal position at 0 degrees. So if we take that segment and we rotate it this far, we know that we have rotated it a positive number of degrees. Okay, again, this is 0. If we rotate this way, we know that we have rotated a negative number of degrees, creating a negative angle. This is a positive angle, this is a negative angle. Okay, and then the other thing you need to write is rotations are negative when they rotate clockwise. And I know that's really kind of, in my brain, I always go, okay, which is it, because it doesn't feel normal. But you've got to remember it that way. Is a 90 degree is always traveling counterclockwise, whereas a negative 90 degree is always traveling clockwise. So positive 90, counterclockwise. Negative 90, clockwise. Positive 90, counterclockwise. Negative 90, clockwise. Okay, got to get that in your brain so that you remember it. And that's all that I have for you. In your practice today, you are actually, or tomorrow in class, you are actually going to have to rotate them, and the degrees are going to tell you how much, so you have to pay attention to these two things that I just told you. So going back to our goal, today we will practice the rigid motion called rotation. A rotation is when you turn a figure a certain number of degrees around the center O. So what must be present for a rotation occur? You must have a center point. They will give you the center point. You have to use that center point because that center point is what determines how you move it. And remember, this is your center point in my drawing. And remember, on this transparency, you have to trace the center point wherever it is because that tells you how to move your figure by keeping it on the center point as you turn the transparency. Okay? So what must be present for the rotation to occur? A center point. Okay? And that's all I have for you today. I'll see you all later. Bye!